Hello, this is Soumya Rastogi, and welcome to this presentation on software risk management. In this video, I'm going to talk about what is risk and risk management, why is it important, what are the steps, and how do I ensure that I have done right. A risk is a potential problem for a software project. It might happen, it might not. But regardless of the outcome, it's a good idea to identify it, assess its probability of occurrence, estimate its impact, and establish a contingency plan. Software is a difficult undertaking. Lots of things can go wrong, and frankly, many often do. Understanding the risks and taking proactive measures to avoid or manage them is a key element of good software project management. Before diving deep into understanding the risk management plan, let's look at the 7 principles of risk management. First, view software risks within the context of a system in which it is a component and the business problem that it is intended to solve. Second, think about the risks that may arise in the future, for example, due to changes in the software, and establish contingency plans so that future events are manageable. Next, if someone states a potential risk, don't discount it. If a risk is proposed in an informal manner, consider it. A consideration of risk must be integrated into the software process. The team must be vigilant throughout the software process, modifying identified risks as more information is known and adding new ones as better insight is achieved. If all the stakeholders share the same vision of the software, it is likely that better risk identification and assessment will occur. And lastly, the talent, skills, and knowledge of all the stakeholders should be pooled when risk management activities are conducted. Recognizing what can go wrong is the first step, called risk identification. It is a systematic attempt to specify threats to the project plan. Generic risks are a potential threat to every software project, but product-specific risks can be identified only by those with a clear understanding of the technology, the people, and the environment that is specific to the software that is to be built. One method for identifying risks is to create a risk item checklist. Its subcategories include product size risks, which are associated with the overall size of the software to be built or modified, business impact risks, which are associated with the constraints imposed by management or the marketplace, stakeholder characteristics, which are associated with the developer's ability to communicate with the stakeholders in a timely manner. Process definition defines risks associated with the degree to which the software process has been defined and is followed by the development organization. Development environment risks associated with the availability and the quality of the tools to be used to build the product. Technology to be built risks are associated with the complexity of the system to be built and the newness of the technology that is packaged by the system. And lastly, staff size and experience risks, which are associated with the overall technical and project experience of the software engineers who will do the work. We can also determine if the software project we are working on is at serious risk by asking certain questions, like have top software and customer managers formally committed to the support of the project? Are requirements fully understood by the software engineering team and its customers? Does the project team have experience with the technology to be implemented? And so on. If any of these questions is answered negatively, mitigation, monitoring, and management steps should be instituted without fail. Finally, project managers identify the risk drivers that affect software risk components, performance, cost, support, and schedule. The impact of each of these risk drivers on risk component is divided into one of four impact categories: negligible, marginal, critical, or catastrophic. Negligible impact results only in inconvenience. The additional cost required to mitigate the impact is very low. Marginal impact affects secondary mission objectives or requirements, but do not impact overall mission success. Cost is somewhat higher but manageable. Critical impact directly affects system performance and requirements and may bring mission success into question. Cost to mitigate is also high. Finally, catastrophic impacts result in mission failure. The cost of mitigation is usually unacceptable. Next, each risk is analyzed to determine the likelihood that it will occur and the damage that it will do if it does occur. This is called risk projection or risk estimation. It attempts to rate each risk in two ways: the likelihood or probability that the risk is real and will occur, and secondly, the consequences of the problems associated with the risk should it occur. The intent of the step is to consider risks in a manner that lead to prioritization. No software team has the resources to address every possible risk with the same degree of rigor. So, by prioritizing risks, team can allocate resources where they will have the most impact. A risk table provides us with a simple technique for risk projection. We begin by listing all the risks identified using the risk item checklists in the identification step, no matter how remote, in the first column of the table. Now, before moving forward, please pause the video and try to identify which items in the risk assessment table belong to which items in the risk identification checklist. I'll give you 10 seconds for that. Okay, I hope you have been able to classify most of the risks. Let's see. Product size risks are associated with the overall size of the software, so the first three risk items can be safely assigned to it. Business impact risks are associated with constraints from management or users, so risks related to deadline and users belong to this. Funding and requirements depend on the developer's ability to communicate with the stakeholders, so these risks belong to stakeholder characteristics. Risk items related to the complexity of newly built software belong to technology build checklist. And lastly, the last three risk items related to software development team clearly belong to staff size and experience. Now coming back to the risk assessment table, each risk is categorized in the second column. For example, PS implies a project size risk, BU implies a business unit risk, and so on. The probability of occurrence of each risk is entered in the next column of the table. It is worth noting that risk assessment does not always need to be recreated from scratch. Developers can reference risk assessment table for a previous similar project and see which risks apply to the current project and which do not. Next, the impact of each risk is assessed and an impact category is determined. The categories for each of the four risk-driving components, performance, support, cost, and schedule, are averaged to determine an overall impact value. Once the first four columns of the risk table have been completed, the table is sorted by probability and by impact. High probability, high impact risks move to the top of the table, and low probability risks drop to the bottom. This accomplishes first-order risk prioritization. A project manager then establishes a cutoff line at some row in the table, and all the risks that lie above the cutoff line should be managed. The column labeled RMMM contains a pointer to a collection of risk information sheets developed for all the risks that lie above the cutoff. During the early stages of project planning, a risk may be stated quite generally. As time passes and more is learned about the project and the risk, it may be possible to refine the risk into a set of more detailed risks, each somewhat easier to mitigate, monitor, and manage. One way to do this is to represent the risk in a condition transition consequence format and divide the condition to further detailed subconditions with the same consequence. An effective risk dealing strategy must consider three issues: risk avoidance, risk monitoring, and risk management and contingency planning. If a software team adopts a proactive approach to risk, avoidance is always the best strategy. This is achieved by developing a plan for risk mitigation. As the project proceeds, risk monitoring activities commence. The project manager monitors factors that may provide an indication of whether the risk is becoming more likely or less likely. In addition to monitoring these factors, a project manager also monitors the effectiveness of risk mitigation steps. Risk management and contingency planning assumes that mitigation efforts have failed and that the risk has become a reality. The RMMM, or the Risk Mitigation, Monitoring and Management Plan documents all work performed as part of the risk analysis and is used by project manager as part of the overall project plan. Each risk is documented individually using a risk information sheet. It contains a description of the risk identified, probability and impact information from the risk projection step, the conditions and the subconditions defined in the risk refinement step, and lastly, risk mitigation, monitoring, and management steps. Once RMMM has been documented and the project has begun, risk mitigation and monitoring steps commence. That's all for this presentation on software risk management. Thank you so much for watching.